Hello, my name is Steve Hanley,
And I'm Rob Parent.
and we are part of the enDAQ product team, and we are going through introducing Python to you all as part of this series. We've showed you how to install Anaconda, which includes Python, some libraries, different environments to run in. Now we've done other videos with showing Colab, which is basically a Jupyter notebook executed in the cloud. Then we showed you what a Jupyter notebook is, which is running Python code locally from the Anaconda navigator. And now we're doing Spyder. And Spyder is going to look and feel a little bit like MATLAB if you're coming from the MATLAB world. With that, we'll get started. And as I'm opening this, I will explain something else. So again, we installed Anaconda. So I'm here in the Anaconda navigator. That's where Jupyter Lab is. Here's Spyder. But I'm going to also just launch Spyder directly.
Yeah, you don't have to open Anaconda, the navigator, every time.
Yeah. And we notice that everyone in Python likes to put the py in their names. There's PyCharm, there's Spyder with py, there's Jupyter with py, there's NumPy, there's SciPy.
There's a lot of
There's
options.
others. Okay, here is Spyder. And so as we're bringing this in, again, if you're from the MATLAB world, you'll probably be a little confused maybe, where MATLAB is, you open MATLAB, it's just MATLAB. And when you open MATLAB, that gives you access to all the libraries inside of MATLAB. It gives you access to just executing and writing MATLAB, and the environment is MATLAB. You think of all those things as one thing, but in an open source environment like Python, libraries are independent of Python itself, which is kind of the core. And then the third thing is these environments, these IDEs, where you actually access the libraries, you write code, and you execute using Python.
Yeah, so if you're new to Python, I think what would you recommend? Jupyter Notebook or Colab, or it depends on what you're trying to do.
Yeah.
But if you're coming from another place like MATLAB, finding an IDE that fits your workflow, like Spyder, is probably how you want to go.
Yeah, exactly. If you're coming from MATLAB, Spyder is a good entry point. Spyder is good if you are going to be writing scripts and then kind of hitting go again on new data sets. So it's maybe not as exploratory, although you can be very exploratory, where you use this console on the bottom right to kind of, and we'll do that now. So, but then Jupyter is more exploratory. It's you kind of start with an input and you write a little bit of code. You see the output of the code. You do markdown text in real time, so it's good for like building a test report that you would then share with somebody else.
Right. Yeah, that's worth specifying. If you're just new to Python, the world is kind of maybe.
Yeah, you can play around with a few things. And then another one is PyCharm, and that's for like building up proper applications. I think our audience that's watching this video is more the typical mechanical engineer they have some data looking to analyze it. Mm-hmm. So Spyder would be good, Jupyter would be good, and Colab would be good, depending on what you prefer. And so check out the videos here. So here, the bottom right is my console. I can make new variables. You'll see here in the variable explorer, there it is. I can say x times 2. All I'm going to test Rob's math skills. I'm going to say y equals x times 50.
50, 100.
Let's see. Oh, he's right. Okay. And then I can just hit y and print it out, and you also see it here. So the variable explorer, I will say, is really nice, and something when I first started doing Python, I really missed in some of the other environments, although Colab has now added it. There's ways to add it in Jupyter as well. But Variable Explorer is certainly nice. Over here is where we write our code. I'm going to do a new file, and I am going to say import pandas as PD. And I think when I do this, I can also, and you can change the layout here. You can add new panes, move them around. I'm going to add this little online help pane, which could be nice. You can kind of search pandas.readcsv. Aha! So it shows you the,
Yeah, great.
Now, of course, you can just do that in Google. You can also do it in real time here, and I'll say data equals pd.readcsv. Remember, I'm going to be giving it this file location with single backslashes that Python does not like. So I had to add the R in the beginning to make my single backslashes double backslashes. You can do that manually as well. But here's the CSV of data. And I'm just going to run this simple script. I'm going to save the simple script, actually. Save. And save it on the desktop. Shockanalysis.py. Yes. All right, then I'm going to run it. And you'll notice here my variable explorer now is this data frame. And if I print it out here, and you can also just double click, I think. Aha! Which is nice. You'll notice that this isn't exactly what I want. I want to treat the time column as my index. So I'm going to go to this. So I'm going to rerun the script by saying index call equals 0. Yes. And then rerun it. Okay. And now, when I double click this, which is nice, it sees treating the time as
it's separate from the rest of it.
Yes.
Yeah.
All right. But we want to make a plot. So then we're going to import plotly.express as px. There's other libraries. Matplotlib is very popular. Plotly's better. In my opinion, the reason is it once you get used to the interface, it's the world's your oyster in terms of what you can edit, although Matplotlib is like that as well. And Matplotlib's interface is based on MATLAB. So if you're coming from that world, it is maybe a nice transition. But the big difference with Plotly is it's creating figures that can be opened in a browser. So they're interactive, they're dynamic, they're easy to share. I can send that to somebody who doesn't have to open Python, doesn't have to have Python installed. They can just open it in the browser and start interacting with it.
You'll develop your own preferences too, but we have our own as well.
But the only downside in Spyder is because Plotly is using this JavaScript to make their figures really rich in a browser, you don't necessarily have that rich interactive environment and feel in Spyder because it's not in a browser. So there's a couple ways around that, and that's when you're using Jupyter or Colab, that's in a browser. So the Plotly interactivity is right there. But we're going to do fig equals px.line and data, and I'm going to choose. So in Spyder, I can show this, but I have to specify the renderer equals .png. So it's going to basically render it as an image. And when I do this, it should show up over here in plots if I didn't screw something up. I screwed something up. Oh, I didn't install a library. You need the Kaleido library to render Plotly figures as images.
That's what Kaleido's doing.
Yes. And so you can install libraries with pip install and then the library name. You can do that here. You can do that in the Anaconda Navigator. We'll do it right here. And this should take a moment. Hopefully. We might need to restart the runtime after this. Yes, restart the kernel. Consoles, restart kernel. And when I do this, I'm going to lose my variables, but that's okay. Yes. And we need to whenever you install a new library or you update a library, you'll need to restart the kernel because it's just gotta start fresh. Okay.
Restarting the entire.
Now if I run this, you should get something. Ooh. Yes. What did I do? Here we go. So there's the plot that shows up as a PNG. This is nice.
Yeah.
Okay.
You can't zoom in or anything like that.
No, I can't. But it is a variable here, and I can show you what I can do with this second. But it's nice. This is the variable explorer. It's 22,000 data points. So that's fine. I can, though, do fig.write.html and say shock pulse. Aha! And I don't know where. Oh dear. Where is this? I think this is in your, right here. There it is. And now I can open this in the browser. And Rob uses, what are you using? Brave?
Brave.
Super Brave. Oh, that's not the right one. This is OCPSD. That's not the right one. Which one do I want?
Is that not the right one?
Where did I save this? Oh, I think I saved this on the desktop because that's where my Python script is.
Right.
But let me, there it is, shockpulse.html. Okay. And here it is. Nice. Zoom in, and away we go. All right, let's make our script a little bit more advanced. What do we want to do? For one, before we do any plotting, we want to maybe find the peak.
Yeah.
Let's find the peak.
Sure.
All right, so one way to do that, we can kind of test our code over here, but we would do data.idxmax. Nice. So this is, I'm going to do data.max. So this is, so idxmax is the index at which the maximum value occurs. There's 3 columns, so the index at which the maximum value occurs could be a different time, and you notice like they're slightly different.
Right. So
in order to just pick one unique maximum time, I'm going to do first get the absolute value of my data, then take the maximum across each row, which I think axis equals 1, and then I do idxmax. Oops. And there it is. All right, so I'm going to add this to my script. I'm going to say data.index minus equals.
what's that?
Minus equals, good question. That means I could say equals data.index minus this variable. This is the same thing as saying minus equals. I just get rid of this part.
Gotcha.
Makes it a little cleaner.
Yeah.
Okay. So now my peak event will be time 0.
Right.
Because I have taken the max time and I have subtracted it from the index. I've taken the time at which the maximum occurs and subtracted it from the overall time. So that means my time at the maximum will now be 0. So I'll make my plotting later on now a little easier.
Will your plotting now show negative time leading up to the max? Or will it...
Exactly.
Okay.
And so I'm then going to also reduce my, let's say I want, let's see, let's look at this. So it goes from 100, what was that, 1,037 to 1,039. Now if I look at my plot, we probably only need to plot 0.2 of a second.
Yeah. Yeah, I think so. It's a good, yeah.
So we're going to also reduce our data to equals data negative 0.2 to 0.2. Actually, I'll show you guys this in real time. And I'm going to just comment this out, which I can do with, all right, we'll run this again. And if I go data 0.2 to 0. Now I should do negative 0.2. Now, it's sliced it basically till just 4,000 data points.
A lot more manageable.
A little more manageable, so we'll do that. Equals data negative 0.2 to 0.2. So we're plotting 0.4 of a second around the peak event. Well, we've reduced our data to that. Then we're going to plot it, and we're going to save it as an HTML as well. What did I call it? Shock pulse. HTML. Okay. there's a plot that updated.
Yeah.
You see that? I can, and that looks good. And if I come over here to my desktop, here's the interactive version. And there we go. Now, this is a shock pulse that is, if you notice, you can kind of see there's a lot of high frequency component going on here, but generally there's this lower frequency and much more energy dense pulse here that's going to about negative 55 Gs or so. So I just want to show you quickly, and there's other videos on filters that dive a little deeper into this, and tutorials that go farther. But here's part of this video to make it a little different than the previous ones. We will do some filtering. So we're going to import the enDAQ library to do this. We're going to say data equals enDAQ dot calc dot filters.
And you want to install the enDAQ library prior to this, which we've touched on in other videos. But
yes, and you would do pip install enDAQ to do that. Now it's nice here in Spyder, it is telling me, it's giving me like the doc strings to see what parameters I have available to specify. You can also go to our documentation online, docs.endaq.com, and you'll see examples and nice, pretty, more stylized documentation. But you have it right in real time here, which is certainly very helpful. So we're going to pass in our data, and I'm going to say the low cutoff equals 2. Now, yeah, I'm going to say none. I'm going to not. Low cutoff is basically the low frequency that you want things be above to be passed. So it's actually a high pass filter cutoff.
right.
Might have been a little bit confusing with the parameter name, but if you don't know, yeah, it's actually more straightforward for people that don't necessarily know what high pass and low pass filters are. People always get confused about that. They always think a low pass filter is focusing on high frequency content.
Yeah, you're allowing the high frequencies to pass through, but it's high pass.
Yes, exactly.
Low cutoff.
So we're going to filter at 100 hertz. All right. And I am going to also just remove, instead of doing a Butterworth filter, I'm going to remove the median from my data. So data.median. And you can't see this because of our big heads. There we go. And now I'm going to plot this again. And I will call this filtered. Also, once I've imported the enDAQ library, I'm going to set endaq.plot.utilities.setTheme.
Gotta make it look good.
I like my themes. And I think that's it. So if I run this, I should get 2 plots. And if I can, do I click in here to clear all these? Remove plot. Do I gotta remove these variables? Yes. Run again. I should get 2 plots. One with filtered data, one with unfiltered data, and we can take a look at the difference. Plots. There you go.
Nice.
That's filtered. This is unfiltered. And we can look at the desktop. And here are 2 pulses. One has the nice enDAQ theme on it. And you notice, you can see what I was talking about where this, the y-axis has this big heads in the way. We're going to go make our head super big. So you can see that it goes through about negative 60 or so. And when you look at the unfiltered data, you can see that here. It's just got all this high frequency component on top of that.
Makes it a little easier to read.
Yeah. But we go into more of this in other tutorials on frequency analysis and filtering and shock analysis with using shock response spectrums. But hopefully this is a pretty good overview of Spyder, which is a good environment for people coming from MATLAB. It's all in one place. You have your scripts you're running over here. You have your plot outputs over there. You have a variable explorer. You can kind of probe your variables here in the IPython console and get started. But that's just one of many different environments you can choose from. Again, we have other videos for Jupyter and for Google Colab, and there's more out there.
Yeah, choose whatever's right for you guys.
Yeah, and check out our other blogs in this series and other videos in this series to help you get started in Python, which is free. It's generally more capable than MATLAB, believe it or not, because it's open source and it's being adopted so rapidly. So there's a lot of libraries out there. And of course, enDAQ has released a Python library that has a bunch of functionality to interact with our data files, but also just do nice and easy vibration and shock related analysis, plotting, interacting with our cloud API. Maybe one other thing I'm forgetting. Oh, configuring our devices. All
Right.
sorts of things. All right. Enjoy. Till next time.